As Harold promised, I will give a bit more detail about the aspect of CARRA real-analysis system and the input. And given that Harold already gave a quite a comprehensive overview about the systems aspect in CARRA, I think I will put a bit more focus on the ongoing efforts toward the CARRA tool. So just a recap about the CARRA analysis. That the main characteristics, of course, is on the very high resolution aspect in terms of the grid size. I mean, it is really a kilometer scale regional analysis that we have a resolution of 2.5 kilometers for grid distance, and that is in contrast to the 31 kilometer in the global analysis of Area 5. So we are putting a lot of more details in the systems, and a basic strategy there is that we start from the state of art weather forecasting system used for operational, which is at the 2.5 kilometers, and as Harold said, is the one that used at the weather forecasting center in Denmark, Iceland, and Norway, currently for the European Arctic areas. And so we draw benefit from these mature systems, and we run it for the real-analysis proposal, of course, with a lot of adaptations. And I said for the main deviations from the system we use for operational proposal, which is, I think, one of the major deviation is that instead of using a global forecast as a lateral boundary, we use now Area 5 real-analysis to constrain, and that actually is quite significant. I come briefly back to that. And the other thing is, of course, that we have opportunity to have to look at enhancement in terms of the representation of high resolution features, especially at the surface, and about the description about four things, focusing especially on the cold surface, as Harold mentioned, and also as was showed in Harold's presentation, that we put a lot of more offline in situ observation data on this area, especially for the European Arctic, which is due to historical reason and also population distributions that is very sparsely spread it. And so whatever extra observation we can use, we take great efforts to collect them and use them. And we have improved on physiography and the high resolution sea surface temperature and ice data, and snow cover data by satellite, of course, is quite poor coverage by the in situ measurement for these areas. And we make use of satellite-derived albedo data for the glaciers, which could be quite important for these areas. And as mentioned in Harold's talk, that we also have used this ice models to take care of the consequence only with snow cover over ice, and it turns out to be quite significant in improving on the description of the things over the ice covered areas. And of course, we adapt the data estimations streams and that of output in order to adapt for the real-analysis purpose. As mentioned for the CARRA 1, the real-analysis period covers for a 30-year for the start, and now we are in the near real-time phase. And probably it's interesting to especially to mention that for the as said in the large part of these Arctic areas is traditional data spots. You look at this Greenland, the biggest island in the world. Traditionally, if you look at the data use we have for the operational weather forecast, they are they are represented by these observation sites along the coast, which is numbered around 30 to 40, which is really quite small numbers if you look at the size of the island. And also for Iceland, traditionally is not very well represented by synoptic data. And then in the reanalysis, we managed to collect a lot of data from that are done over the ice sheet, and also for Iceland is a great enhancement. Look at the color difference between the blue for the real-time collections and the red that is traditional offlines. So this is quite a significant enhancement for Greenland. I think it's almost a doubling over the institutional data sets. So now we have a good representation, or better representation, at least for the ice sheet. So just one more evidence on top of the verifications results that have been shown and will be shown on the surface parameters. We also noticed that because of the use of the ERA 5 reanalysis as lateral boundaries, this improves quite greatly the simulation of the large-scale parameters also in the digital models, which traditionally is handicapped because of the fact that we have to use the time-lagged forecast boundary from global models. And now, because of the use of the reanalysis, you could also see that if you look at the verification scores, the comparison between the errors compared to sounding data for the CARRA in green color and that of the ERA 5 in red colors, it's quite seldom you see that between regional and global models that the large-scale parameters such as the mean pressure and the vertical profiles of temperature and wind and the relative humidity are actually much better than in the limited area model than in the global model, which is very seldom seen in the operational database. Now we are coming from the CARRA 1 to CARRA 2, and the one of the most significant change, of course, is the area coverage, and that is significant if you look at I mean, they may not look at that as significant, but in terms of the number of grid points, actually is almost a increase. I mean, the new domains with the number of grid points is almost 4 times that of the original one in CARRA 1. So it's quite a significant increase in the data volume. And we will try to stick to this grid size of 2.5 kilometers. And we have upgraded in this new coming systems from the Cycle 40 H1 based system to that of Cycle 46. And with slight increase in the reanalysis data series from around 30 years to that of 35 years. One of the major changes, as Harald already mentioned, is the use of the improvement of the surface schemes from relatively simple one to that of a multi-layer surface statistics. And basically for both the land surface soil explanation representation and snow, we go from very simple ones to those of many layers, and following the trend that is now also ongoing in different weather centers. And we are also trying to incorporate with machine learning based uncertainty estimation, try to give a bit more information about the uncertainty from our products without running ensembles. As Harald said, that this is still a things to handle with the cost issues. In terms of these new service schemes, some of the details are given here. It is a upcoming Surface version 8.1 schemes that is now also being sort of adapted to the weather models with 14 layers for the diffusive soil schemes and for 12 layers for the snow, and explicit multi-layer schemes, canopy schemes for better representation of snow. features, and it will be having one additional patch for forest. And now we have moved this physiographic database to that of a second generation, so with some improvement. And accordingly, we have adapted now the service destinations using the ensemble common filters for the analysis of soil temperature and moistures. And the new schemes for the snow analysis. Just a showcase of the significance of these new service schemes, which you have seen in the real-time runs for the weather forecast that we have had for a long time a deficiency in our systems about the representation of snow melting and the thawing process in the Scandinavia areas or Arctic areas in general. That we suffer as shown by these bias figures in the surface temperatures, in the soil lower level temperatures, huge biases traditionally, and now is thanks to these new schemes, it is improving quite a lot. So in terms of data simulation, as Hara said, that we have traditionally we have less good infrastructures about the capability to simulate the satellite data, and we are improving also on that in the CARRA tool. So what is circled here in the red colors are the ones that will be simulated in addition to what have been done in the CARRA 1. So we are also improving on those the data use. And yes, quickly that we are now in the phase of doing intensive development to get the system ready for CARRA 2 production, which is to start in the spring of 2024. And as we've been doing in CARRA 1, that we will be doing the production in multiple streams, more completely divided into 7 streams, with the probably priority only near real-time ones starting from the late of 2019, about the mosaic period. But at the same time, we will launch also the production for the other time slices at the same time. So we hope that we can get it ready by the time of the required deliveries. I think that's about all I have to say. Thank you.